Started. So this is some important exam one information that hopefully you guys are aware of. Everything on this slide is available on the exam one practice or information and practice page on Canvas. It's just right under your week 4, I believe, just at the bottom of the first column. Just keep a note that you do have one full page of your handmade notes. That just means that you wrote them yourself. You're not sharing them with classmates. You're not copying and pasting everything. Just make sure to take your time to make your note sheet because that'll really help you in the exam, especially when you get stuck. You're not allowed to bring anything other, any outside tools, no calculators. I've never done a proctored test before, and I've never been a proctor or been to any of those, but just know that no calculators are allowed. The calculation should be fairly simple. Your test is majority weeks 2 to 4. There's a little bit of week 1, but it's those textbook sections. There's a few sections in them that aren't covered. The full information is on that exam 1 page. You should be able to finish it in about 60 minutes, but you are given 80. You're free to go over time, but there is point penalties. And then this was taken off of the Canvas. I summarized every single point that was on that big table. And then these are the topics that we're going to try to cover today. Maybe not in major depth, but hopefully at least clear up some different points of confusion. And then this whole PowerPoint will be posted along with a video. So hopefully that is fine for you guys. Maybe this will be better. All right, so we have our linear functions and equations. This is our first topic that hopefully everyone went over. Hopefully you're familiar with y equals mx plus b, where y is your output, x is your input, m is your slope, and then b is your y-intercept. This is something I highly recommend you have on your formula sheet, even the definitions, especially the definition for your slope, know how to use them, and know what to do to graph your line. So we're going to do a quick breakout room. We have this equation or this problem where your slope is equal to -1/3, your x-intercept is equal to 2, and I want you to find the equation of the line, and if you have time, go ahead and graph it. Feel free to take a picture of the screen so that way you can have the question in your breakout rooms. I'll give you guys 3 minutes and I'll go ahead and do 3 rooms. So it's about 3 to 4 people per room.
So I was confused with the x-intercept. I didn't know if you meant y-intercept or if that was covered in the last chapter because I didn't get to that chapter yet. But you meant x-intercept, right? So instead of a y-intercept, it's an x-intercept. So instead of doing the 2 on the y, you go 2 on the x, right? Yeah. Positive. And then the rise and the run, -1 and negative, is it -1 and -3?
So -1 over -3 would just be a positive because you have 2 negatives. So it's either one is negative.
Oh, okay.
Both the top and the bottom can't be negative. Does that make sense?
Yep.
Cool. So was anyone able to get an equation or even a graph? If anyone was able to, feel free to click the annotate and see if you can draw what you got on my little hot pink graph. So that'd be perfect. Even like at least the x-intercept, you guys know what that is. And just a reminder, the annotate button should be like on the bottom of your screen. It's a little circle with a pencil on it. Great, thanks, Lily. All right, and then was anyone able to draw? All right, no worry, we can get that going. So we've got our x-intercept here. Oh, that was great. You've got your intercept. Do you want to finish up that line? I think it's there's like a little line shape button that might help. All right, so just for the sake of time, I'm gonna go ahead and show you guys the next slide. Oh, sorry, that was great. I just clicked off of it, but this is what it should look like. The intercept for y is actually at 2/3. So when you, sorry, 3/2, I believe. So this is what your graph looks like. Did you guys feel like 3 minutes was enough? Was it not enough time? This one was a little bit more challenging.
So why did it become 2/3?
I believe that's an error on my end. Let me double check something. So our x-intercept is at 2. And then, yeah, it's 3. My apologies. Should be 3/2. Because we run 3 and we technically go down 1, right? So from this point to this point, we have a slope of -1/3. Cool. So we'll have our y-intercept at 3/2. And then don't worry, I don't think you'll be given anything this difficult on your exam. I just kind of wanted to make you think about what the difference between the x-intercept and the y-intercept is. So the way to approach this problem, if you had anything like it, is that you could make your x-intercept is when your x equals 0, right? Or sorry, your y equals 0 and your x is at 2. So then you can plug in your numbers and then solve for your y-intercept. All right, let's go ahead and move on. So let's do an absolute value problem. So anyone that's able to annotate, feel free to start filling numbers. And remember that this is an absolute value function, not parentheses. So those lines mean absolute value or the distance from 0. We're going to fill out this table and then we're going to graph it in the next one. So is anyone? And if you can't draw, go ahead and tell me any of the numbers. So like where x equals 0, does f of x equal? So we've got 2, 0, minus 3, plus 2. This goes to 0, we get -3, absolute value of -3 plus 2. So then at x equals 0, we get 3 plus 2, which equals 5. Cool. Can anyone do where x
I have a
equals 1?
question,
Yeah.
Holly, really quick. So how come that changed from -3 to just a 3? Is it because it's in between those absolute value bracket things? Okay,
Yeah, so anything in the absolute value automatically gets its
right.
value changed to a positive number.
Okay, thank you.
Great, okay. Can anyone do the next 3 just really quickly? I can go ahead and do x equals 3 if someone wants to do 1.5. 2 times 3 minus 3 plus 2. This goes to 6 minus 3. staying in the absolute values because you want to simplify everything in the absolute value before moving on. So we have 3 plus 2, which is also equal to 4. Do we have any questions on how to solve absolute values? All right, sorry, 2 times 2 is 4. Okay, Evan's got it. Awesome. And awesome. Thank you guys. All right, so let's go ahead and graph this. So we'll keep this table in mind. I went ahead and put it all nice and neat and then graphed it. So our first point, just in case that this doesn't quite make sense. So at 0, we have an f of x, or our function of x is our output. So we can technically plot it as a y value. So we technically have an x and a y here. So at 0, we have a value of 5, which you can see here. So x equals 0, y is equal to 5. And then our second point, we have at x equals 1, right? And then we have a y of 3, so it goes all the way up to 3. Same thing with the 1.5. It's about here, we have a value of 2. And then at 2, we have a value of 3. And then at 3, we have a value of 5. So absolute values always do this kind of V shape. It can be this way or upside down like this. Depends on the negatives and the different shifters, right? So just keep in mind that like your typical f of x equals absolute value of x starts at the origin of 0 and then has that slope in the middle. So everything that we've done here is that with this equation, we've both shifted it and we've stretched it. So I don't know, I don't think you guys have gotten this far yet, but if everyone, as long as everyone is comfortable with doing the table and plotting those points and connecting those points, you'll do great on the test. All right, so next up, we are going to go over the domain and range. Do you guys, can anyone tell me what the domain is considered? You can go ahead and chat if you'd like, and go ahead and read those out loud if you'd like, if you don't feel comfortable talking.
It's the first value in the ordered pair, right?
Yeah, so
Number,
it's
letter.
it's the like containment of all of our x's, right? So it describes our x, and then the range describes our y of our function. Hopefully that is familiar. You'll do like the interval notation with the 2 different parentheses and the 2 top and the bottom point. So in this case, our domain or our x values spans from negative infinity to infinity. Why is this? Well, because when we look at it, our arrows will go all the way from negative infinity on the x and positive infinity. These go on forever. So as it increases forever, we can't contain it. So it goes in the x direction, both positive forever and negative forever. And then we make sure that we have this curved parentheses and not the closed bracket, because infinity cannot be a bracket. It can't be included in a value, because infinity is a weird number, technically. All right, and then our range is all of our values of y. So in this case, our range is exactly at 2, because remember at 1.5x, our y is equal to exactly 2. And that is the lowest point that we'll ever have, right? Because our absolute value always goes in that B pattern. Do I have any questions on domain and range? And then if you have any questions, you can always click that participate button and then raise your hand, or you can put it in the chat. Now let's go ahead and move on. So really quickly, Hanlon wanted me to go over the definition of a function. So the definition of a function, if you look it up online or if you'll look through your textbook, it's that every single domain has exactly one range. So this means, in more English words, every single X input has exactly one Y output. So in this case, we've got two different figures. We've got figure labeled 5 and figure labeled 6. In our figure 5, every single one of our X's has exactly one Y value. So as you can see, every single X has only one Y. There's no duplicates. Where in our second figure, we have the 6 having two different Y outputs. Right here, we have 6 with two Ys. The second one is not a function. This is not a function. And then there's something else that we can consider when doing functions or not. This is the vertical line test. Hopefully you guys are familiar with it through Alex, but it is when you graph your function, can I draw a vertical line and it does not intersect more than once with my function at that point? So in this case, as I draw vertical lines on our first one, only one intersection happens at every single one of my lines. I can think of just dragging this line across, and if I only have one Y output, then I'm good, right? So then in this case, our second one, our f of x is not a function, because as we drag the line, we have multiple Y outputs. We've got 2 at this line, and then we've also got another 2 at this line, and then more at these lines. So whenever we drag that, and if we get multiple, it is not considered a function. Okay. So our right figure does not pass the vertical line test. We see that x1 has 2 Y values. To be a function, x must only have exactly one Y value. I would recommend putting this on your formula sheet, or at least remembering how to do the vertical line test, as well as maybe the more like English definition of a function. That second one might be useful to write in your formula sheet. All right, so I was not able to get the polls to work. I was trying for a while, but it wasn't quite working. So we're gonna go ahead and use the hand gestures. So if you think that this is a function, go ahead and give me a thumbs up. If you don't think it's a function, go ahead and give me a thumbs down. And if you don't know how to use that, it is on your 3 dots. You can click those, and then you can, or even on the bottom, it's that smiley face. It is in your reactions. If you're on mobile, click the 3 dots, and then hopefully it should pop up. Okay, we've got a lot of thumbs downs. Great. All right. So everyone agrees that this is not a function. Great job. Because it does not pass the vertical line test. That's our first way of seeing how it is or isn't a function. Any line does not pass it. Good job. All right, let's do another one. Same thing. Thumbs up or thumbs down. Is this a function? Right. Thumbs up if you think it is, thumbs down if you don't. All right, we've got a few thumbs up. Nice. All right. So everyone seems to agree that this is a function. You guys are correct. Yeah. So it passes that vertical line test at every single point. We only have one Y value. Fantastic. So really quickly, we're going to go over f of x notation. I've realized that it has been quite confusing as a point of just doing different things. So this is actually read as f of x notation. So hopefully if you didn't know what I meant by f of x, it is this right here. So it just f of x represents our output, and then y represents, or x represents our input. You've been already doing this with our y equals mx plus b. So f of x notation allows us to do transformations on our x. So I don't know how familiar you guys are with this, but all we're doing is when we have this here, our f of x minus 3 means that on our equation of f of x, every single place you have an x, you're now replacing it with x minus 3. So then when you have more than one thing replacing your x, you have to FOIL. So because we're doing a x minus 3, you need to FOIL. So this is our original function right here. And then I want to make it f of x minus 3. So then I need to FOIL each side and then simplify. So this will look like f of x minus 3, right? Because we're transforming our original f of x function. And then that should equal to 2x minus 6 plus 3. Did I lose anyone? Give me a thumbs down if I lost you, or if this makes sense, give me a thumbs up. Here we go, one thumbs up. All right. And if this is confusing, I can always stay late and go over it more. But for now, we're going to go ahead and graph this. So all I've done is went ahead and graphed it. This is slightly different. I changed the intercept so it would fit better on the graph. So this first one here, this green one, is our original function. And then the second one is our f of x minus 3 function. All I did was FOIL and then simplify. So when I FOIL and simplify, I get 2x and then negative 6 plus 1, which is negative 5. So my y-intercept is negative 5. As you can see, negative 5 is down here. And then my slope stays the same. It's still 2 in both of the functions. So all we did when we added that notation is we moved the entire line down 6 units. So remember when we FOILed, right? We FOILed this out here. What we did with our second FOIL is we got, so we have 2x, right? And we've got negative 6 plus 1. So these combine into our negative 5, right? But all we did technically is we moved that intercept down this many units that we FOILed earlier. All right, we'll just keep that in mind. Hopefully that makes sense. And then we'll go ahead and move on to the next step. There's that written as well, in case you forget. We're going to be solving some inequalities. So just going over some of the properties, when you add and subtract an inequality, the same must be done on both sides in order to keep the inequality true. When you multiply and divide by a positive number, you have to do both the same. You have to do the same on both sides, and then your inequality sign remains the same. But when you multiply or divide by a negative number, you have to flip the inequality sign. This was, I believe, quiz 2 or 3. Hopefully you guys are familiar with this. Hopefully you remember this, but keep in mind, every time you divide by a negative, multiply by a negative with your inequality, you have to flip it. Just a quick example. I won't make you guys do this one, but whenever we want to solve for x, we would first add 5 to both sides, and then we get 2x is less than 12, and then we would divide both sides by 2. So we get x is less than 6. All right, that was a really simple example. We only used the first 2 properties, but I do have another one for you guys to do in the breakout rooms. I'll give you guys a little bit more than 3 minutes, so hopefully you guys can turn on your webcams and chat a little bit about what you guys get, and then those will be open now. All right, welcome back, guys. I just want to close those early, mostly because I didn't see any of you guys talking. So hopefully on the next one, we can get some people talking. So looking in the chat, looks like 2 people got x is less than or equal to 2. So in order to solve this, I guess I can go through it because we have some questions. So the first step is to FOIL, right? Everyone remembers foiling. Bring whatever term up front and then distribute it to every single one. If there's more than one term up front, do that again. All right, so we get negative 3/4 x plus 6/4 less than or equal to 3. We can subtract 6/4 from both sides. And remember, 6/4 is the same thing as 3/2. So let me start that up here a little bit better. Hopefully this is, there we go. This is wider. Hopefully you can see it better. So then, oh, except it doesn't. All right, we'll just go ahead and continue. So then we have negative 3/4 x is still greater than or equal to, right? Because we're still adding and subtracting the same on both sides. So we don't need to change the inequality sign. We get 3 minus 3/2. Does anyone know what that is? Which is also the same as 3 minus 1.5, right? Okay, so we're left with 3/2 up here. I lost anyone? We're still good.
I'm lost.
Okay,
Did you get rid of the 3?
so all I did was in this step right here, I subtracted both sides. So this step, right, I subtracted both sides by this 6/4, which is the same as 3/2. Because I want to get rid of the 6/4 to get x by itself. So I subtracted both sides by 6/4, which is the same as subtracting it by 1.5. So then when we have 1.5, or 3 minus 1.5, we get 1.5. Does that make sense?
So it's negative 3/4x plus 6/4 greater than or equal to 3, and you subtract 6/4 on both sides. So wouldn't it be negative 3/4x plus 6/4 greater than or equal to 3 minus 6/4?
Right, so when we subtract both sides by 6/4, we can actually cancel these out.
Well, yeah, so it would become negative 3/4x is greater than or equal to 3 minus 6/4.
Yes, which is, so 3 minus 6/4. Right, so we can put it over a common denominator if that makes you feel better. We can do, well, let's first simplify. So we'll do divide the top by 2, divide the bottom by 2, right? Because we have common terms or common denominators. So we can do 3/2. That just simplifies that. So then 3/2 is the same thing as 1 and 1/2. So then when we subtract 3 by 1.5, we get 1.5. So this is equivalent to 1.5. Does that make sense? Yeah, you can also times everything by 4. There's a few different ways to approach it.
I have a
Yeah.
question. So when you changed that to 1.5, then it became, sorry, it became a 3 times 1.5.
So we're subtracting, right?
Oh, what the heck? Yeah, so it became 3 minus 1.5.
because we're minus, like it's 3 minus 6/4, which is the same as 1.5.
Okay.
When you simplify
So-
6/4, that's 1.5.
So then it became 2.5? Or are you doing in that different? I'm so confused.
So all this is these two are the same thing. So 1.5 is the same thing as 3/2. Because when we have 3/2, we have 2/2 plus 1/2. And then 2/2 is the same thing as 1.
Uh-huh.
Yeah, so we have
Okay.
1.5.
So where did the 3 go?
So the 3 was subtracted, right? So let's do in our pink, right? This step right here. This step right here, they're both the same.
Oh, okay, sorry. Yep, never mind.
All right, great. So now that we have that, we can divide both sides or multiply both sides. Let's do multiplication of the reciprocal. Let's see if I can get my colors working. So we're gonna multiply both sides by the reciprocal of what we're trying to get rid of, because we're trying to get x by itself. So we want to get rid of the negative 3/4 term. It's not, colors aren't working. Okay. So multiply by 4, negative 4/3 to both sides. And we have to flip the inequality, right? So we get x less than or equal to -2. Right, and it looks like a few people got that answer. Do I have any questions, right?
No, I got it. Thank you.
All right, be sure you know how to do this. Make sure you know your rules, and that'll really help you on the exam. This one is a harder problem. I don't know if it might be about the same or easier. So hopefully if you can understand this, then you should be good for the exam. All right, so now that we've done that and we've figured it out, can anyone go ahead and annotate with the interval notation? So what we were doing earlier with the parentheses or the brackets. Anyone give us the X interval notation? So that's just the span that this equation goes out on from. So what's your X equal to, right? So does anyone not understand the question? I can rephrase it.
Yeah, I don't.
Yeah, do you guys remember those number lines in the very beginning where you drew on where your X spanned from? So when we're doing the like closed dots and open dots, right? Looks like Miles wrote the closed brackets, so that's
Yes.
including, yep. All right, great. So this is great.
Is that
And
right?
then-
Or did I get the
yeah,
second part
that's
wrong?
great.
Because I always get it mixed up.
Oh, that's great. Okay. And then what does this look like graphed? So I just give us a quick little number line. Then you guys remember how to do this. So I'll let anyone do that. In the meantime, just remember that our closed dot means including. And then our open dot means up to, but not including. Great. So that looks great. Do we have any questions on what has been?
I'm still kind of confused how you got -2 from
3 over 2 times negative 4 over 3.
Yeah, so let's see. Really quickly, I can go over that. So when we had what, 3 over 2, and we had it multiplied by negative 4 over, no, that's not quite, we had it 4 over 3. So when we multiply this, we can do it across, right? We can multiply across and we'll get like a bigger numbers on top and on bottom. Or we can also do the cross multiply method where what's the best way? Okay, let's just go ahead and multiply across. So when we multiply across, what do we get on the top? 3 times
12.
12. Okay, what about on the bottom?
I understand now. I was treating it
Oh,
like
okay.
addition, but I just like that just like clicked. But if you do the reciprocal, doesn't that turn it into a positive?
So on the right side, yes, or on the left side. So when we multiplied this by the reciprocal, we multiplied it by 2 negatives, right? So on this side of the equation, we get negative 4 times negative 3, which is just 12. And then we get 3 times 4, which is just 12. So this side goes away to 1. Does that make sense?
Yeah, it does.
All right, if we have no other questions on inequalities, we'll go ahead and move on. It looks like we're almost out of time and there's quite a bit left. But I don't mind, I can stay as long as we need. Simplifying expressions with exponents. So this is a very handy table that I pulled off the internet. Hopefully you guys have seen every single one of these rules and understand how to use these rules. Because these were on quiz 5 and these will be on your exam. Make sure you know how to use exponent rules, especially with your base powers and how those affect it. This is definitely at least like one of the minimum things I would put on your exam formula sheet. And then I'm not going to do breakout rooms, but I'm going to quickly go over how to do this. Or I won't go over breakout rooms, but I will give you 2 minutes and then see if you can get the answer. And then I'll go ahead and work it out while I give you guys some time. Cool. Yeah. So this one you have to remember to FOIL. So it wasn't necessarily anything with our exponent rules. This one was making sure you keep your exponents together and then make sure you FOIL. So in this little corner up here, I've got my work shown. So all I did is I multiplied it, right? And multiplication, we just bring it to the top of the denominator. I FOILed it into both of them. And then I went ahead and got this answer. Hopefully that's what you guys got too. Technically the correct way is to have it in alphabetical order, but either way, b squared a is the same as a squared b. Right, do I have any questions on this one? I know we're going kind of fast. All right, and then there's another one. Hopefully you guys remember on quiz 5 with your exponent rules and what to do with a negative exponent. If you don't, it's just right here. Then I'll write smaller this time and do it along with you guys. Anyways, you guys won't get anything that needs this much arithmetic. You don't need a calculator. You won't need a calculator at all. Hopefully you do know what this ends up being when you simplify it. We can we can divide both by 8. So 48 divided by 8 is our 6. 16 divided by 8 is 2. We get 2/6, which simplifies into 1/3. Wait, yeah. Hold on. Did I mess up? I did. Would you guys end up getting? Did anyone? Neat. Sorry, I think I messed up when I was doing it. It's been a really, really long day. Sorry, guys. We have a -4. We're gonna go ahead and just move on because it's got 3 minutes. We don't have much.
What was the mistake that you made? I didn't catch it.
Let me go ahead and figure this one out.
Okay.
When I put it together, I got 12, but it was also 3 a.m. So I'll go ahead and double check on that. I think this is our last topic though. So systems of equations, hopefully you guys are familiar with these. We did spend quite a bit of time on the last 2 quizzes doing these. So I guess the biggest concept in a system of equations is to get 2 linear equations that contain 2 variables. So hopefully you guys are used to the substitution method where you solve for 1 variable in the first equation and then substitute that into the second variable. And then you can solve for the second variable to get the 2 different variable answers. And remember, when you do these, you can get 2 different special cases. So you can get infinitely many solutions where you cannot solve for a variable. When you plug it into the second one, you get like a constant equals constant. So in like quiz 5, some people got 7 = 7. So whenever you plug in for one of the variables, you will get the same for the output, regardless of which equation you plug it to. There's also another situation where you will not have a solution. This is a system containing like parallel linear equations, so you can never create a intersect or like a solution for them because they have the same slope but a different intercept. Hopefully that makes sense, and if not, I can go over it more. Really quickly, if you guys talk in breakout rooms, I can break you out into rooms. It doesn't look like, I think other people are just as tired as me. So, well, you guys are free to take a picture of this and then solve it in your own time. And then I'll also post these slides. But this is considered a special case. The lines will never intersect and they will have no solution. So looking at this really quickly, without solving all of it, I can tell that they're the same line because looking at the bottom equation, every single term in these contains a like common factor. So we can divide everything by 2, which is the common factor. And we know everything is divisible by 2 because every one of those is an even number. So then we can get 2x plus 3y equal to 4. So I guess this isn't necessarily the easiest thing to see, but we do have, we can, I guess, I'll keep going. So when we put it into y equals mx plus b form, or even just move y to one side, so it's similar to y equals mx plus b form, we can do the same with the top one. -2x. We can see that our slopes are the same. We can kind of ignore this 3 in this case because they're both the same on both sides. And we have 2 different y-intercepts. So these lines are parallel. I guess they go. And then you'll also have the word problem version. So hopefully everyone understood quiz 5 where we did the apples and bananas. Your goal with 2 systems of equations is to relate the 2 different variables and the 2 conditions using 2 equations. That's a lot of words. So we've got like our apples and bananas, those are 2 variables. We've got the 2 conditions, our money and the number of fruits, and we want to create a relationship between the 2 equations. So given our cost, that's one of the conditions. We have the cost of the apple and the banana. So then we'll create an equation for those. And then we also want to create one with the number of fruit that we can buy. So we want to relate the apples, the bananas, and then the number of fruit. So this is very similar. All I did was change the numbers. When the apples cost $1.20, the bananas cost 50 cents, and I only want to spend $9 on fruit. I've got, but I also want 11 pieces of fruit. What are my 2 equations? So hopefully this is familiar. We have our money condition. We related our cost with our apples, and then our cost with our bananas. And then we also related the cost that we want to spend at the very end. So we'll have those 3. Right, this relates to this. Banana cost here, and then the total cost here. All right, and then we also want the number of fruit, and we know that we want 11 of them, so my apples plus my bananas is equal to 11. All right. So then now that we have these, we can go ahead and solve. So this PowerPoint goes through every single step, and then on the side, it tells you what I've done at each step. So I've replaced A for my money condition equation, and then, or I've solved for A in our number fruit equation, and then I replace it into the money condition. I FOIL it through, and then I subtract the 1320 from both sides, divide both sides to get my B, or my number of bananas. And then continuing off of that, you can go ahead and plug in your B into the first equation, and then that solves for the number of apples. I should get 5 apples and 6 bananas to meet my 2 conditions. I did that really quickly, but hopefully that is familiar. I will have another review session on Friday, and hopefully people are more energetic. Hopefully it's not as late and as tiring. I'll do a few different examples. Hopefully they'll be a little bit easier and easier to discuss. The slide deck and the recorded video will be posted by 10. And then if you would like, if you can't make it to Fridays because your test is tomorrow, even Friday morning, I have created some take-home problems that you can go ahead and solve for. I recommend trying these at least once. It'll be very useful. It's good practice for what will be on your exam. So if you have any other questions, thank you so much for coming.